Hello, today we're going to talk about the pixel art generator program in this case. So first of all, we will start with the database. The database is just, in this case, one table, which is designed this way. First, I store the core name, which is the name I received from the client, the full name, which is a name generated by the API, which is a unique ID, and the pixelated boolean value, where I can check if the image was already pixelated or not. The image is created since I started the Docker Compose the Docker container with the Docker Compose engine in this case. So I just pass the script and then the container create the database. Docker Compose start both the API and the database. So both keep running and the API just connects and links to the database. Then let's move on to the API. The API, I got the entry point, which is the app, which I just set up all the routes and cores, the middleware I'm gonna use in the application, and load the application and serve it. I got the model for the database connection, where I just connect to the database and return the database object so I can use it through all the application. For the roads I got the image roads, which is the main roles of the application, in this case of the API application. So I got three endpoints. One for test if the image was already picked. If test if the image already exists in the application. So if the image already exists, I want to upload it again. And then if the image does not exist in the application, I upload the image using the other endpoint, which a post image, and I pass the form data object. Then I return from the test. I return the data I have stored earlier in the database, where I got the image unique ID and the image URL. And after I upload the image, if the image does not exist, I return the same response, the image URL and the file name of the image. Then I got an endpoint for pixelate the image, where I received the image unique ID. I got that image which already exists in the application. I pixelate it using the middleware, in this case the pixelate middleware. Pixelate the image using the GIMP library JavaScript. I resize the image to 512 by 512 pixels. Then I return the resized image pixelated, but I return as well a bitmap of the image, which is even more resized, even resized again, smaller than 512 by 512. It's resized to 64 by 64 pixels and return that bitmap. And that bitmap is what I use in the front end for render the image using HTML and CSS, and scale it up to 512 by 512 pixels. And I got another two middlewares, one for upload the image, where I got the image uploaded into the server and return the unique ID generated. And the other middleware I am using is the pixelate middleware, the database middleware, where I got different utility functions for what I use in the database. One to find if the image already exists in the database, another to insert the image in the database, the image name, and another to update. When the image is pixelated, I update the pixelated column in the database so I can check later if the image was already pixelated. And the test middleware, what I'm using to check if the image already exists and return that object. Then we are gonna move on to the front end. In the front end, there is the app.tsx entry point, where I set up, in this case, the provider to provide the storage I got from Redux to all the whole application. I got a configuration for each library, in this case Redux. Got a configuration for Redux, the configuration for Saga, and the configuration for the reducers in separating different files. Got a utils folder where I got different libraries I made to get a code cleaner. First, I got the API where I declare all the endpoints I'm gonna use in my application. In this case, the post image where I'm gonna upload an image, the pixelated image where I'm gonna request for a pixelated image, and the test image. Right here, I just declare the endpoints, and as you can see, I got a make request function, which I'm getting for an abstraction of the make request process. I got defined that make request functions in the network file, where I define the available methods I'm going to use, um, the endpoint and the headers in defining the making request process, validating errors or whatever. So if I get a make request, as you can see, when I get a method different than get, I use that body. But if there's get, the body is useless, so I don't need the body. Generate the, in this case, append the headers, generate a response, and make the fetch. Get a response, and then if there's any error, I just throw it, and with a proper format, so the front end can check out if there was an error in the backend or in the front end, because I got the different defined errors, server error in this case, or bad format error that I strong from the front end. Then I got an image processing API I did to get a pixel uh, in the bitmap, to get each pixel when I'm going through the image from the 0 position of the image, recording from uh, 64 by 64. I get the x and y position, so I map it through the position into the bitmap. That function will return each value for RGB values of the pixel, so I can use it to fill the color of each div, the background color. Then I got a model. In the model I got the dashboard, which is the unique model I got in my frontend application. In this model you can see the actions I'm gonna use. There are very few actions, because I just need to test an action to test if the image was already uploaded. If the image was already uploaded, I just put it into the storage of Redux. Then an action for upload the image, for request upload for the image, if the image was successfully uploaded and if there was any error. And as well for pixelate image, I got an action to request pixelate the image to success. I got a reducer where I process each of those actions and store it properly into Redux. For Saga, I got separated, split the code into 3 Saga functions. One for test if the image exists, so I take the action, construct the body params, and call the test image endpoint. I define it in the API, pass it through the body params, get the response. If there's any image already uploaded in the database with that name, I return that image and put it into the storage. And if there was no image found, there wasn't any image found in the database, I request for upload the image. And then that process is processed by the other Redux Saga, where I take the request, construct, in this case the file I'm gonna upload, taken from the form data, send the image to the API through the call effect of Saga. Call the endpoint, get a response. If the image was successfully uploaded, I just put it into the storage of Redux. And if was any error, there was any error, so I return a server error in this case, because there was an error uploading the image. And the pixelate Saga, where I send the request of pixelating an image, construct the body, and then call the get pixelated image from the API. And as well, if there was an error, I just throw an error, and if the image was successfully pixelated, I just put it into the storage of Redux. And my favorite part is here where the components exist. There are different presentational components, but my favorite one is this one, the image to CSS, where I got the bitmap, which is 64 by 64 pixels, and scale it up to 512 by 512. But render that bitmap using HTML and CSS with the background color. As you can see here, I put it background color and scale it up, making the height size of each div, in this case of 8 pixels, and defining the width of the container with 512 pixels, and making flex with a width of 1, which is gonna stretch over each div in the flex container and use the available space. So it will scale it up to 500 by 512 by 512 pixels, the 64 by 64 bitmap image. So I'm gonna make a quick example. I got here the server running using Docker Compose. You can see the Postgre and the API is already up. So let's check it out. I just got an image. In this case, the image already exists. It won't be updated. Just took the object, pixelated, and we'll load a bit, and then show the image. And as you can see, each of those pixels are representing a div, which I generated here. And okay, that's it.